Hi up, this is the third video in independent probability. The first one covered concepts, the second one covered example one, and you can see it on your screen right now, and the third one is one more example. And this is from page 353 in your textbook, but I've added an extra bit to it for us to explore. So the question is, suppose the probability of owning a television, in the textbook it says that a family owns a television, is 0.75, and the probability of owning a station wagon, the event own a station wagon being S, is 0.25. If these events are independent, find the probability of, and then there's a couple of questions there. So let's go through them one by one. So part A is, what's the probability that the selected family, the randomly selected family owns both? Well, we would start off by saying owns both means that the probability of A and, I'm just used to putting A's in, the probability of T and S, or T intersect S, is equal to. We're told they're independent events, and so we can simply say 0.75, oh no, I better do it, I'll do a bit slower, is the probability of T multiplied by the probability of S. So there's my two probabilities multiplied together because they're independent events. The probability of T is 0.75. The probability of S is 0.25. And so we just multiply them together, which I'm just going to use my Spotlight calculator to do. 0.75 times 0.25, and I get 0.1875. Good year, that. So 0.1875. That's it. That's all you have to do. Part B, what's the probability that the family that was chosen at random owns at least one? Well, that's one of those sort of ones where they're sort of asking you to work out, what are we asking you, in a way. At least one means that they own either a television or, there's a key word, or a station wagon, or both. Okay, so it could be both. So that fits the description of T union S, right? If you think about the Venn diagram, it would mean this circle and this circle, as well as the intersection in between. And we know that from our probability calculations that we would have the probability of T plus the probability of S. Because of that double up in the middle, we need to subtract the probability of T intersect S. That's our formula. Well, I can substitute actually a value in for all three of these. So the probability of T is 0.75. The probability of a station wagon is 0.25, and luckily in part A, we've got 0.1875 as well. So we've got all three parts that we needed. But it just might be worth pointing out that this is fairly common in that you might be asked to work out what the probability of T union S is, and you're told they're independent. So you would just replace this statement here with probability of T times the probability of S, and then work it out. It's just that in this question, it's already been calculated in part A, so we don't need to do it. But yeah, you could effectively just replace that with that. Okay, get my calculator out again. So I've got 0.75 minus 0.2, plus 0.25. Oh, I reckon I could have worked that out in my head, couldn't I? Plus 0.25 minus 0.75 times 0.25, and I get 0.8125. I couldn't have worked that bit out in my head, but I reckon I could have worked out 0.75 plus 0.25. So 0.8125 is the probability. Note that I'm not ever changing them into percentages. There's just nothing really to be gained from it. We would hope that anyone who's reading these probability problems would be able to convert these into a percentage if necessary. So there's no need to sort of spend time. Part C is new, it's not in the textbook. Given the family owns a television, what's the chance that they also own a station wagon? So this is the probability that they own a station wagon, given that they own a television. Now, I wonder if you can remember back to the first video where we started talking about what this means conceptually. Now, if the events are independent, that means that what happens with one event has no impact on what happens in the second event. So the probability of S given T would be just the probability of S. All right? It has no impact. And that's 0.25. And you're done.